We're on problem 47. 47 on page 281. If the two floors in a certain building are 9 feet apart, how many steps are there in a set of stairs that extends from the first floor to the second floor of the building? So I think I can draw that. So this is the second floor. This is the first floor. They want to know how many. They're 9 feet apart. That's what they tell us already. 9 feet. We need to figure out how many steps there are to go from the first to the second floor. So, piece of information 1, they give us. Each step is 3/4 foot high. Foot high. Well, this by itself should give us enough information, right? Because each of these distances, I'll do it in green, each of these are 3/4 foot high. So to figure out how many total steps to get to the top, you just say 3/4 times the number of steps is going to be equal to 9. And then you could just solve this by multiplying both sides by 4/3. But we don't have to solve it. We just have to know that we can solve for it. So 1 alone is enough, right? And you could, if you multiply both sides of this, you get 12, that you need 12 steps. But anyway, we want to avoid having to actually do math. We just want to figure out whether we can do the math. Piece of information 2. Each step is 1 foot wide. 1 foot wide. Well, that's clearly useless because it doesn't tell us how much, I guess, altitude we're making on each step, and that's what you have to figure out to say how many steps you need to go up 9 feet in the air. So this is useless. So the answer is A. Statement 1 alone is sufficient. Next problem, 48. 48. If xy is equal to 0, xy, does not equal 0. So that tells us that neither x nor y is 0, right? Is xy going to be less? Is x divided by y going to be less than 0? X divided by y is going to be less than 0. In order for this to be true, one of these numbers, if x divided by y is negative, that means that either x or y, but not both of them, are negative, right? That's the only way you can get a negative number when you're dividing. If both of them were negative, this would be a positive number. So let's see what we can do with their information. Number 1, x is equal to, and this is the question, is xy less than 0? And 1 says x is equal to minus y. Well, immediately, let's just substitute that back in. If x is equal to minus y, then what's x over y? X is equal to minus y, so you have minus y over y. And that will equal, and we know y doesn't equal 0. So for any other value other than 0, if this was 0, this would be undefined. But then this is equal to negative 1. So in this case, this is x divided by y is equal to negative 1, which is definitely less than 0. So that proves our statement. So statement 1 alone is all we need. Now let's see what statement 2 gives us. I'll do it here. Statement 2, minus x is equal to minus y. So that tells us that minus x is equal to y. And then we could just substitute the same thing in again. We could say, well, now we could substitute for x. Or we could just multiply both sides by negative. You get x is equal to minus y, which is the same thing as this here. So statement 2 alone is also sufficient to solve this problem. And so the answer is D. Each statement alone is sufficient. Switch colors. Problem 49. Problem 49. How many people are directors of both company K and company R? Okay, directors of K and R. Okay, statement number 1. There were 17 directors present at a joint meeting of the directors of companies K and R, and no directors were absent. At a joint meeting of the directors. So that's all the directors of K and R. So let me draw some Venn diagrams. So if that is K and then that is r. So they're saying that when you add both of these together, because this is a joint meeting of all the directors of both, we got 17. So there's 17 in this entire universe of directors. That's what statement 1 tells us. That this circle, that if you take this whole circle and then you add up the extra, don't double count the intersection, you add up the extra, you get 17. But that alone doesn't tell us how many joint directors are. Joint directors are these people, people who are on the board of both K and R. So this is K and this is R. So statement 1 alone doesn't help us, although I'm suspecting maybe in conjunction with something else it could. Statement number 2 is company K has 12 directors and company R has 8 directors. Okay, K is equal to 12 directors. 12 directors, that's an I. And R is equal to 8 directors. Okay, so everything in this, in the K circle combined is 8, right? Everything in the K circle is 12, right? K directors. Everything in the R circle is 8. Now, if we wanted to get the total of the K and the R, so by itself, that doesn't tell me how many overlap. So when you take statement 1 or statement 2 independently, that doesn't help us. But what if we were to figure out if we were to use them together? So how many total directors are there going to be? There's going to be the total directors in K, so K's directors, plus the directors in R. But if you were to just add those two up, you would double count the people who are in both K and R, right? You would count them twice. You would count them when they're in K, and you would count them when they're in R. So if you wanted to figure out how many total directors there are, you would then subtract out the people who are in K and R, right? You don't want to subtract them twice. You just don't want to double count them, right? Because when you do K plus R, you're counting them for K, and then you're counting them for R. So let's subtract them out once so that, I don't know, you only count them for K, or that you only count them for R. You only count them once. So minus KR, so this notation, that's people who are in K and R. And what does that equal? Well, statement 1 told us that. It told us that there are a total of 17 directors. And so statement 2 told us there are 12 directors in K, plus 8 directors in R, minus the joint directors is equal to 17. And by the way, we don't even have to do this. We could have just recognized that if we know the total number of directors and we know how many are in each of the groups, that we can figure it out, and we would just answer the question that both statements together are needed to answer this, are sufficient. But I'll just show you that we can figure it out just so that you're happy with it. So let's say we get 20 minus KR is equal to 17. And so you get KR is equal to 3. So there are 3 directors that overlap with both, and we were only able to answer that question by using statement 1 and statement 2. Next problem. 50. If x and y are positive, so x, y are both positive, is xy greater than 1? xy greater than 1 is a question. Statement number 1 tells us xy is greater than 1. So let's see, does that help us at all? And that's not obvious. That just tells us that x is greater than 1 over y, or y is greater than 1 over x. So let's just think about it. This statement is equivalent if we multiply both sides by y, and we can do that without changing the inequality because we know y is greater than 0. So if we do that, we get x is greater than y. This is, if we can show this, we can show that. And remember, the only reason why I didn't have to change the inequality is because I knew that when I'm multiplying both sides by y, that y is greater than 0. If y was less than 0, I'd have to switch the sign right here when I multiply both sides by it. But anyway, if I can prove x is greater than y, we're all set. This doesn't help me. Let's see. Statement number 2 is x minus y is greater than 0. Well, if I add y to both sides of this equation, what do I get? I get x is greater than y. So this proves exactly what I need to prove. And if you want to go all the way to what originally they asked, divide both sides by y, and we don't have to change the sign because y is positive. You get x divided by y is greater than 1, which is exactly what we needed to prove. So statement 2 alone is sufficient. See you in the next video.